I'm going to write the mechanism for this reaction. So the first step is draw the alcohol, make sure to draw the lone pairs, and draw HBr with a bond. And now the first step will be attack from the lone pair of the oxygen at the hydrogen of the bromide, hydrogen bromide, and then this leaves, and this is the first step, which leads to the formation of what we call the oxonium ion, or the protonated oxygen plus Br minus. Since this is an SN1 mechanism, and how do I know that this is an SN1 mechanism? Because this is a tertiary alcohol. The second step will be breaking of the carbon-oxygen bond, and this leads to the formation of a carbocation plus H2O. Remember that the formation of carbocation step is always the slow step. Now after that, since this is a tertiary carbocation, it's not going to rearrange, so I can finish this mechanism by just drawing the attack from the bromide at the positive charge or the carbocation, and this leads to the formation of the product. And this is the first mechanism in the exercises sheet. This is basically number 9. Second mechanism. So the second reaction is this one. So we have a secondary alcohol plus HCl. Now pay attention to this. This is going to rearrange. So I will explain in the mechanism how did I end up with this product, although you should know it by this moment. So the first step is again protonation of the oxygen. So this is the OH. This attacks the HCl, and this leads to the formation of a protonated oxygen, or the oxonium ion plus Cl minus. Second step is always breaking the carbon-oxygen bond to form the carbocation plus H2O. Now, look at this carbocation, and you have to always do this. Whenever you have a secondary carbocation, check for rearrangement before drawing this last step, which is the attack of the bromide or chlorine. Since this is a secondary carbocation, and if it moves to this position, it's going to be a tertiary carbocation, so that's why rearrangement will take place and the carbocation will be here. Now this position has a hydrogen, so hydride shift will take place. So this is a hydride shift, and this is how I draw it. And now I have the rearranged cation. Now I finalize this mechanism by drawing the last step, which is attack of the Cl minus at the carbocation, which is going to give me the product which I draw here. Okay. Third mechanism. This is just a repeated one. So this is secondary plus HCl, and in this case there's no rearrangement, because this is secondary, this is secondary, and this is secondary. So there is no way for rearrangement to take place. Plus H2O. Again, first step is protonation, and this leads to second step. Take this oxonium ion, and break the carbon-oxygen bond. This leads to the formation of a carbocation. Again, as I mentioned, this carbocation is not going to rearrange. That's why I just draw the last step immediately, which is the attack at the carbocation. And this leads to the formation of the product. Nothing here. Okay, now this is the other example. Now we have a primary alcohol plus HBr. Remember that primary alcohols react by SN2 mechanism, which means that there's no rearrangement. You just have to replace the OH by Br. That's it. So the first step is, again, it is the same thing in all mechanisms, which is protonation of the oxygen. And this leads to the formation of the protonated oxygen plus Br minus. Remember, this is an SN2 mechanism, which means that you are not supposed to show the formation of a carbocation. So it's going to be a direct displacement mechanism. What do I mean by that? So basically skip this step, because this is only for SN1, and draw the attack directly. So this is the carbon bonded to OH, the minus charge attacks here, and this goes up, and it leads to the formation of the product directly. There is no carbocation because this is an SN2 mechanism. Why it's SN2? Because it's primary. Okay, plus Br plus nothing, plus H2O. Last example. So we have a quaternary carbon, and next to it we have a secondary alcohol. Then you should know that this is going to rearrange. This is secondary, this is primary, so no rearrangement to this position, but this is quaternary. So rearrangement will take place by methyl shift. The easiest way to draw a methyl shift is the following. Pay attention to this. Keep the bond as they are. I think I added an extra carbon here, right? Yep. Okay, so keep the bonds as they are. So basically keep this bond as it is, keep this bond as it is, just move the OH to here. Okay, as if I did a methyl shift, and I will show you in the mechanism how did I do that. So let's go to the mechanism now. The first step is so obvious. It should be so obvious by now. This is the, again, HBr. Okay, this goes here. Don't you think that this way of showing the solution of exercises is better? At least you know how do I think in doing this. Plus Br minus. I love technology because it enables us to do beautiful things, but sometimes it just goes crazy. Okay, so now again, second step, this is an SN2 mechanism, SN1 mechanism. Again, SN1, why? Because it's secondary. Break this bond, form a carbocation. Now look, this is a secondary carbocation. Next to it there is a quaternary center, so it's going to undergo a methyl shift. How do I draw a methyl shift? Simply draw the arrow from the middle of this bond toward this bond. This is how you draw a methyl shift, and make sure to write methyl shift. And now pay attention to this bond, which is the methyl, moves to this position here, and the positive charge will be at this point. Now last step, which is going to be the attack by Br minus. Just draw it anywhere and make sure to attack this position here, so that you end up with this beautiful product. Br here, It doesn't really matter if you draw the BR from this position or this position, it's the same thing. So okay, well, undo. Okay, no, undo. Okay, I think these are the mechanisms which were in the problem solving yeah. So I'm done. Thank you for watching this video. This is how I write my name. Can you write from right to left? This is my name in my language. Okay, we don't need it. Thank you for watching this video. Good night.